Hi everyone, I hope last video was very useful for you. It was based on the basic concepts of trigonometry. Now let's do some problems in 8.1. Here we have to find tan p minus cot r. The figure is given. PQR is a triangle right angled at Q and PQ is 12 centimeter, PR is 13 centimeter. We have to find the answer for tan P minus cot R. Let's start with, okay, we are in need of QR, side QR. To find the unknown side, we are going to use Pythagoras theorem. According to Pythagoras theorem, PR square, that is the hypotenuse square, is equal to the sum of the squares of the other two sides. So, PQ square plus QR square. Here we know that PR is 13 square, PQ is 12 square and QR need to be found. Okay, so 13 square is 169 and to take 12 square that side, 12 square is 144. Now, the answer is 25 QR square. So, we are in need of QR. I take the square to that side which becomes root 25 QR, which is QR is equal to 5 centimeter. Okay, now we need to find tan P, which means the theta lies at P. Now, tan is opposite by adjacent. So, opposite is QR and the adjacent is PQ. So, tan P is equal to QR by PQ, which is equal to QR we found as 5 and PQ we know it is 12. Now, next we have to find cot R. Cot theta, the R angle is the theta now. So, cot theta means adjacent by opposite side. So, the adjacent is QR and the opposite is PQ, which means 5 by 12. Now, we have to subtract both of them. So, tan P minus cot R is equal to 5 by 12 minus 5 by 12, which is equal to 0. That's all. So simple. Now, let's do another problem. Given 15 cot A is equal to 8. Now, we have to find sin A and secant A. So, it is given as 15 cot A is equal to 8, which means that cot A is equal to 8 by 15. We know that cot theta is adjacent by opposite. Now, let's draw a triangle. Let's name it as A, B and C. Now, the theta lies in A and is right angled at B. Let us consider it is right angled at B. Okay. Now, according to the cot formula, cot A is equal to adjacent by opposite. So, AB by BC, which is 8 by 15. Then, it must be AB must be 8 and BC must be 15. Now we can find AC easily by Pythagoras theorem. So AC square is equal to AB square plus BC square. AC is equal to root of AB square, 8 square is 64 and BC square, 15 square is 225. So AC is equal to root of 289. Now, root of 289 is 17. So, therefore, AC is equal to 17. Now, we have to find sin A and secant A. Sin A, which is equal to opposite by hypotenuse, BC by AC, which is equal to 15 by 17. Then, secant A is equal to, secant is hypotenuse by adjacent. So, 17 by 8. That's all. So simple. Now, let's do another problem. If angle A and B are acute angle such that cos A is equal to cos B, then we have to prove that angle A equal to angle B. Now, let's draw a triangle ABC. It is given that A and B are acute angles. So, obviously, A and B cannot be right angle. So C is the right angled, A and B. Now we have to prove that angle A is equal to angle B. It is given that cos A is equal to cos B. Okay, if cos A, then it can be written as adjacent by hypotenuse, which is AC by AB. Cos B, here it is adjacent by hypotenuse, which means BC by AB. Here we can see that both the denominators are same, so we can cancel out each other. So we are getting like AC is equal to BC. AC is equal to BC. Okay, that is AC is equal to BC. Okay, a theorem is there which states that angles which are opposite to equal sides are equal. Angles which are opposite to equal sides are equal. Now we have two sides AC and BC as equal sides. The angle opposite to side AC is angle B and the angle opposite to side BC is angle A. Therefore, according to this theorem, we can say that angle A is equal to angle B. Hence proved.